Hello, everyone. Just checking, just waking you up. I know it's been a bit of a long day there, and clearly saved the best for last. So I'm here today to give a presentation on that way around. The nuclear supercycle. So just to give a bit of an introduction to myself, I'm Darren Greers. I'm the head of digital for our nuclear and power business at AtkinsRéalis, covering the EMEA region. Background to myself is I've spent about 23 years in the nuclear industry now. Background predominantly in nuclear decommissioning. And I've split my time between AtkinsRéalis, about 10 years in practicing actual engineering, and then 10 years moving away from engineering and into technology and digital and data. A little bit about AtkinsRéalis. Some of you may not have heard AtkinsRéalis. Only a few months ago, this is our new brand for our joining of our organisations between Atkins and SNC-Lavalin. So you'll be aware, you may not be aware, but around about 2017, SNC-Lavalin acquired Atkins, and over the last 5 years, we've obviously been developing a relationship between our two organisations. And I think now we're in a position of where we want to be as an organisation and how we want to reflect ourselves as an organisation, and that accumulates in the brand that we now have in AtkinsRéalis. So we're a global organisation of around about 36,000 employees spread out across the globe, and we operate across a number of markets, delivering all of the services that you can see there at the bottom. So that goes from designing entire cities to delivering nuclear power stations and transforming systems across that full sort of life cycle, as you can see there. Now we have 4 key values that represents our organisation, and we've got a couple of mantras as well, which is sort of connecting people, data, technology, and engineering a better planet, engineering a better future for our planet and its people, and that's all delivered through these 4 key values that you have on the screen there. A little bit about, because we're here at the World Nuclear Exhibition, is around how we as AtkinsRéalis operate within the nuclear industry. We've got an extensive track record of over 70 years worth of experience across the full life cycle. On the right-hand side there is some of the key projects and key areas that we have operated in, from owning, delivering reactor technology, refurbishment, nuclear decommissioning, keeping the current nuclear fleet running. As you can see, full end-to-end, cradle to grave, if you will. Now, one of the reasons why I'm calling it a super cycle, and you'll have heard a few presentations today, and including ourselves this afternoon, about the nuclear renaissance. And I think that's true when it comes to the generating side of nuclear. There is a renaissance and a request for looking for new operating plants. But actually, a super cycle really reflects the depth across the full nuclear life cycle that we're currently finding ourselves in. So just a few key numbers there on that right-hand side. You know, there are currently over 50 nuclear reactors under construction and more than 80 commercial SMR designs in development. So that, from a new build perspective, that's pretty massive in terms of huge construction projects globally. There are currently 420 nuclear power reactors currently in operation. So that gives you the breadth of either plant life extension or current operations that need to be maintained. But then if we look at the front end or back end of that, we have round about 200 of those 420 reactors expected to begin decommissioning by 2050. And if you look at the current decommissioning portfolio, there's around 200 commercial, experimental or prototype reactors, 500 research reactors already retired or in various stages of that decommissioning. And the pull on our industry is pretty big across all of that because of that scale. And if you think about from a decommissioning point of view, decommission needs to be considered as part of any new build. If you think about plant life extension and plant life operation, that's information that needs to be transferred into the current new build programs and also the decommissioning stages. So we need to share the knowledge that we have across that, which presents the challenges. Now, I've kindly taken that diagram from netzeroneedsnuclear.com. And actually, this is the UN 17 Sustainable Development Goals that were distributed around about 2015, I believe it was. And it was a call to action. And I think nuclear actually fits really well into those 17 sort of sustainable development goals. So, and you know, you can go around all of those and see how on the website Net Zero Needs Nuclear actually applied nuclear against each one of those 17 SDGs. So it's really worthwhile taking a look at that, because that really encompasses what we're trying to do for our planet and its people. There is an increase in global energy demand. You know, we're expected to see a 15 increase in that energy demand by 2050, and therefore we need to accommodate that. Electric cars, you know, the use of those and the demand that pulls on systems, and as we move more towards those areas. Knowledge transfer and retention, as I mentioned before, we've got a full nuclear life cycle there from cradle to grave, and actually the knowledge retention is key to being able to support the decommissioning, the operation, and the new build of those. But I think just in the previous, if anyone was here for the previous presentation from Billfinger, they talked a lot about that age that we have, you know, currently 40 years, and we're actually losing a bit of knowledge in there because we have a legacy industry, and there's retirement there is transfer, there is a new blood of people coming through to our industry, but there's a 40-year age gap between the two of them, and are we really transferring that knowledge between the two? And then, funnily enough, if you look at the scale of what decommission and new build and operation looks like, is there actually enough global capability to deliver all of those programs if we're trying to share those skills and those capabilities? So these are some of the challenges that we're facing as a sector and an industry, and I think one of the the fundamentals that we can start moving towards, and the reason for the title around data and digital meeting delivery, is to move us towards a little bit of a data-driven nuclear industry. I think there's a bit of a perception from our current generation generating fleets and our previous new build programs that it can be a little bit archaic and a little bit, you know, these reactors and these sites have been operating for over 30 years, and some of our plants have been operating globally longer than that. You know, you take Sellafield, for example, that's been operating since the 1950s. And we need to move our industry to be more digitally enabled, technology enabled, and data driven. Now, why do we need these? And you'll see that not only are we facing these challenges, but also what does digital delivery methods actually try and solve? So nuclear plants are mega projects, and mega projects do tend to go over budget. There is significant cost overruns within those, and so therefore we need assurance in regards to that. A lot of time actually is wasted during all the phases of delivery in just finding information, and that can be because information stored on bits of paper, it can be stored in people's drawers, it can be stored on hard drives that someone's lost along the way, but also around the fact that even our digital data isn't necessarily stored and structured effectively. It can be stored in Windows folders in 4 layers down, not to a standard set of procedures, and therefore we actually spend quite a lot of time trying to find the information and therefore the answers to the problem that we're trying to solve. So to address some of these problems and to get onto that industry buzzword, digital twin, around about 5 years ago or now, and I still believe that this is quite a neat way of talking about it, is how do we mature our projects through a framework in order to achieve whatever that representation of a digital twin is. And we came up with around about 5 levels of there, and this works across full nuclear or any of the building or construction projects, because it's all about maturing information at the appropriate stages to the appropriate project and meeting the appropriate needs. And so what you have here are 5 levels, and when people are referring to digital twin, I think they actually spend a lot of time talking around that level 3 and above, and that's the expectation from a digital twin, that we have all the information, it's there and accessible, and therefore that we can enrich it with information in order to gain some clear insights and drive those efficiencies, and also that it's then for more AI-driven, autonomously driven, and that actually our digital representation of our project can influence the physical. But what we're forgetting is actually there's a foundation needed in order to get us there. And as an industry, we need to build and mature that information through this scale. And so this scale represents that build. And what you'll also find is that if we take a new build project, therefore it really might be important for the next operating life of its plant of 30 plus years to mature the digital twin to level 3 and above. But actually, if we're looking to digitize or digitalize a legacy facility in order to support its decommission or its plant life extension or keeping it running, do we really need to mature it? And is there really value in maturing that project all the way up to a level 5? And therefore, for example, a decommissioning site, would you go beyond a level 2, or would you only operate certain systems beyond a level 3 in order to aid in those functions? So this is, personally, I believe it's a really neat way of talking about what a digital twin looks like, but also how you mature that through those stages. Second to that, and this is across the industry, I think there's some real common use cases for digital twins, no matter what that industry is. This is on a foundation from building as well as nuclear, but 4 key words there, which is visualize, simulate, optimize, and record. And that's just about linking all of the data together in order to get that value out of that, of which you would mature through that life cycle. Now, in order to get to that digital twin, or in order to drive our industry towards data, then we need to look at some foundations for that. And that's the area that I sort of really want to focus on here. So one part of this is around data modeling and setting your foundations correctly from the start of your project. Understanding what you have and how you then subsequently extract the value of that across that life cycle. Now, an example here on the page there about a data model, that's the data model is there to also look at what data needs to be created, who creates it, and which systems all of that data then exists, and obviously then how do we communicate that out across that teams, and how do we facilitate transfers and knowledge exchange and data exchange and information exchange as part of that. And the purpose of data model, as I said, is the first step. So, this is getting back to your fundamentals to the why in order to extract that value from your information that you have. So a data model is an abstract representation. I think a lot of association with digital twins can be very visual and graphical as well. So we have 3D models, we have animations, we have the ability to simulate. But none of that, actually, the value in that is really in the foundation and in that model that's being data. So, that, to me, is a foundation of a digital twin, if you will. It's a fundamental first step to allow and understand how lots of complex data, lots of different data sets can be integrated and therefore get insights from that. And it can also be used to help identify any missing data that then needs to be subsequently collected or garnered or captured, if you will. Now, some of insights that can actually be extracted through data modeling, and I think this actually lends itself to some of the conversations that we have about artificial intelligence and prompt engineering, is if we have a data model and we have the appropriate data storage and the appropriate information management and how all that's presented, that's how you would get some queries that you might see there on that right-hand side as to, they're the questions I would like to ask of my data, and therefore these are the insights that I would want to garner. But the only way that I can do that is with a foundation of data modeling. Now, data modeling obviously is there to present the why, what do we need to do and how do we do that. Once we have that data, how do we then manage that and deliver that? Now, ISO 19650 over the last few years has obviously garnered into a global ISO in terms of how that might be from a data standard and from a reference data library. And I think, this is almost the way that I've always presented BIM. So as an industry that isn't necessarily around architecture and buildings, obviously BIM back in 2012 and previously was referenced as being building information modeling. I actually like to use the term better information management because that's obviously a fundamental of what we do. And so some key features there on the right-hand side as to how we actually get into that process of information management. 3 areas that I do think are fundamental to this, and especially when thinking about new build programs, is around that creating the common data environment, how you manage that data, and then how you assure and validate that information. So the common data environment is a fundamental. There isn't one solution that fits all, so I'm not here to tell you exactly this is the solution that you should be used, because actually the CDE is determined by the pre-work that you may do. We're looking to empower those teams across the full life cycle to work more collaboratively and use those digital tools, which leads us on to this really wants to be cloud first where we are. Now, as a nuclear sector, cloud does present challenges, sovereignty of information, security of information, where that information is ultimately stored. But we are seeing that assurance coming from either cloud-based providers or from the work that we do as tier organizations or OEMs to work with our clients to assure them that those systems can be used. Because in order for us to really work collaboratively, there needs to be that push towards those collaborative environments within the cloud. A data backbone and how we manage that data, and therefore the data standards in that reference data library is how you then create your integration between the tools in your common data environment, the design tools on how you're going to deliver your new build or design for decommissioning, for example, and then obviously the interactions with the backbone itself. And then finally, if you have all of this set up, then you have your ability to offer that validation and assurance through that. So engineers will be forced to input the right data, in the first time, connecting all of the systems as part of that. Information managers will validate data objects, and then downstream stakeholders will get that value. So actually, ultimately, if we aren't making this information presentable, accessible, and easy to use for operations, for maintenance, for construction and the industry, then what are we doing with that information in the first place? We will get value out of it in the design phase, which is actually a really small phase in comparison to the life cycle of our assets here. So the real value is getting that data right first time, and the value will come through the next phases of that. So this is very much about setting your project up and how you would deliver, say, a new build project and how that might look like on the background. Now, another area, and how do we solve some of those global challenges and people, is also then around providing virtual site access. So if we have a global workforce with global skills and we have projects, discrete projects around in different regions, how do we subsequently bring the capability to the projects without them physically being present? Now, physical presence is obviously something that is still fundamentally important, but if we can provide more virtual site access to our projects using the appropriate systems, whether that is a as-built or a new build project, then we can unlock the expertise that we have globally, but at a local level. So one of the areas that we've certainly focused on as an organisation in the nuclear sector at AtkinsRéalis is around what we call our suite of services, which is virtual site access, and that's around deploying various amounts of technology in order to collect data more efficiently. This is really working well for as-built, so plants, facilities that are already up and running and existing. So it's using things like the technology you'll see across the floor here in laser scanning, drones, quadrupedal robots, for example. And these are the latest methodologies in collecting that information. Then subsequently, the importance of that is how we process that information. How is that information managed? How is it zoned? How is it meet the requirements in order to put into, as you've met within your data standards and your data modeling? And then ultimately, how do we share that information? So once you've got that data structured and stored and accessible, what is the types of technology that would use to bring people to the site virtually? Things like virtual reality, augmented reality, or immersive rooms that you may see across the floor here. So we've seen the value and the importance in collecting and structuring and then delivering that information across that life cycle. And so we've put a bit of emphasis on this. And we're starting to see the benefits of that. So we are deploying this across nuclear sites. We are remotely, we are providing that virtual site access function using quadrupedal robots, for example, here, which is Boston Dynamics Spot. That is giving people access to information. That is giving people access to information that they previously couldn't have because it's accessing areas that they didn't have access to. And the benefits of this and things like this. So if we look about the strategic goals and what we want to be from a carbon reduction and from a sustainability perspective, not physically being present on site and using technology actually garners benefits like this. And we've seen these benefits deployed just across the last year. I've had the 5-minute warning there, so I'm going to quickly skip through a few of this. The video's okay. I'm going to skip through the video as far. So, in the interest of time, that was the video of the services. Now, one of the reasons why I did want to show that video, but I can sort of use it on this slide, is it sort of shows that service in motion, which actually brings a whole lot of skills together that I believe that our industry is developing or will need. If you do want to see that video, then you're welcome to come and see our stand, and I can walk you through that. But if we do want to address those industry challenge, and we need to upskill our teams in a variety of different capabilities, and I believe that our industry will have previously been looking at, and that's just a highlight of some of them that we certainly are looking at developing and also bringing into it. So information management is a key one of those. How do we manage our information, store it, structure it, make it accessible? Data science and engineering, and once that data is accessible, then how do we engineer and provide value and insights on the back of that? As I've mentioned there, from a virtual site access perspective, we are using quadrupedal robots, drones and other robotics in order to not actually have to require physical presence on construction sites or hazardous environments. Artificial intelligence is one, obviously, that we can't get away from, but actually the only way that we can really have the value from AI is if the data is structured and stored and accessible in order to do that. Otherwise, what insights is AI actually delivering to us if it's not using information that is relevant, assured and validated? And then the last one that I do sort of like to touch upon is actually gaming. And I think across these areas, you'll see, especially in gaming, is that it's our next generation are coming through, and they've all had gaming controllers in their hands from when they were 8 to 10-year-old. That lends itself to operating robotics, that lends itself to creating immersive visualizations, that lends itself to augmented reality. But actually, they'll be singly focused on getting into gaming. I want to make the next Call of Duty. I want to make the next FIFA International Football. But actually, as a sector and an industry that's currently going through that super cycle, we require the same set of skills. We just don't necessarily engage with those areas at university level or with graduates or with schools. And I think it's a key part of that, as in, these skills, these areas are areas that might not be traditional to us. It might not be the ones that we do engage with through early careers. And I think this is an area where we should start to looking for talent in order to bring that into our industry. And obviously not forgetting that we still require all of the existing and traditional skills through our industry. This isn't about replacing any of those. This is about augmenting that. And I think that's a key message for us, especially when it comes to robotics. We don't want to be removing, if I take, for example, a glove box operator that may in the future be using collaborative robots. This isn't about replacing those operators with robotics. This is about augmenting their job when they become robotics operators and operating themselves, because we still need that knowledge retention and that knowledge transfer in our industry. And then just the last one for me, to sort of show how serious we are about that nuclear supercycle and where we were earlier this afternoon. As AtkinsRéalis, we actually launched our new reactor technology, which is the Monarch. This is a 1,000 megawatt reactor, but it has a digitally enabled mindset a part of that. This is around modular construction. This is around data-driven and digital delivery in terms of supporting that, because actually what we want to do with this technology and how we deliver this reactor across the regions and across the globe is for it to be digital twin enabled, because we want to deliver these globally. We want to garner those insights. We want to lead and learn. We also then want to deliver them faster, cheaper, and more efficiently. And the only way we can do that is if this isn't built on a foundation of data and digital technology in order to enable that. So just to close on this, If you would like to scan that QR code, that will take us to our digital engineering page, which sort of covers quite a lot of the topics that we have on here. But we're actually positioned in 2 booths. So fortunately, I couldn't show some of the videos and content there. But if you'd like to come and talk to myself or my colleagues about more of that, whether it's Monarch, whether it's robotics, whether it's digitally enabled delivery, then we're actually at 2 booths on here. So you'll find us at booth AB123, which is just down here. And then you'll also find the CANDO and Monarch team at the Canadian Nuclear Association stand. Thank you very much. So do we have any